Okay. Congruent figures. What's going to be true about their size? They're going to have the same size. What's going to be true about their shape? Yeah. Shape is what I was going for. Same size, same shape. Congruent figures. They could be translated, reflected, or rotated, or any combination of those. One to the other. Yes.
Hi.
Hi, Sophia.
Hi, Sophia.
Hi, Sophia. I bet she's not even.
Hi,
Jonah. Hi, Jonah.
Hi, Jonah. Sophia will watch. Okay, so this is.
I guarantee she'll watch.
So this is what we'll do. We'll put in a code word and then we'll know if they watched it.
Right.
What should our code word be?
Keegan, make it Kato. Kato. It's Kato. Banana.
Code word sunflower.
Banana. Wait, what's our code word?
Sunflower.
All right, so if you're listening.
So we'll know if they watched it because they'll know the code word.
We'll ask them.
And you
should clarify the code word. Be quiet.
I already said it so they can hear. Code word sunflower. But that means all 26 of you don't tell them the code word. I know, I don't actually trust you not to tell them.
Yeah.
Also true.
Another code.
Okay, I want you to turn to page 110 and we're gonna identify congruent figures. Okay, so Zach, you said this is gonna be easy. Please tell me. What do you mean solve it? I can't hear Zach. In this, I just want you to identify the figures. Now, what's gonna be important is that we match up the letters with correctly, okay? So, like when I'm matching up these triangles, I need to make sure that if I call this PQR, then I name this, starting with the point that corresponds with P, then the point that corresponds with Q. Do you see what I'm saying?
Yes.
Okay, so let's talk about triangle PQR. Okay, well, P to Q, what's the same segment as P to Q? JK. And then let's just make sure KL and QR, they look like base correspond. Okay, so as we name PQR, it's the same as if we name JKL. Okay. So right now, so it would be some sort of rotation. I'm not gonna worry about it right now. We are gonna have to worry about it right now. Let's just work on naming the congruent in the right order. Tyler.
Like. That's like my.
Well, there's one of our answers.
You don't have to do it. How do you like
I'll wait. I have people trying to ask me questions and there's people also talking to each other and I don't even know who's saying what. Did somebody have a question that they're trying to ask me? Keegan.
I don't even know what corresponds with what for the rhombus or squares.
So those are rectangles. So let's talk about the rectangles. So let's talk about quadrilateral E, F, G, H. Okay, now technically, there's probably a couple different ways that we could name this. But since I named EF first in this order, right? I went from E to F to G to H. Well, E to F named one of the 2 unit length segments. So I better not start naming UV because that would not correspond with this EF. Instead, where can I start?
BS.
No, it'd be
BS.
The V. Open your ears. VSTU, or you could go UTSV. Thanks. Like you can tell I'm still not 100%, right? Like you can tell that.
Wait, were you sick?
He just told me I look like crap. Okay, now let's talk about these 2 quadrilaterals. These are quadrilaterals, right? They have 4 sides.
Triangles, or not triangles, rhombuses.
We're gonna send Cohen back to work on his shapes. These are rhombuses.
Yeah. But why did you draw it like that and not the rhombus? I know, but so? Is that how? That's it.
That's a parallelogram.
I don't know my shape.
Okay, so how about I choose A, B, C, D? Okay, if I choose A, B, C, D to name this, over here, I'm gonna come choose which one first? M and O P. Sounds good to me. Okay, now. Do you agree that in this number 2, PQR is congruent to STU? Do you believe it? Okay. I'm gonna give you about 90 seconds for you and your elbow partner to figure out what the transformation is from PQR to this triangle. What's the transformation? It could be a combination of transformations. There could be 2.
Sophia, can you help?
It's not.
Why are you so pale? And the reflection. I know.
Yeah, we're not sure.
Mine's like.
Yeah, that
They're not oriented the same Yes. Who said my name? Owen, what are you doing? Yeah. Well, I don't think you need to do the 8.
It's 90 degrees.
Okay, let's see.
I literally.
Who thinks they have an idea of how to get there? Oh gosh, Carson first.
Rotation, 90 degrees.
No.
You said I was wrong.
Yeah, you said we weren't turning.
And that's it?
And then you have the line. And then it's y equals negative x. What is it? I disagree.
So let's,
Yeah, you can't do that.
Yeah?
okay, just stop talking and let's look at if it's right or not. So if we rotate this 90 degrees, I'm gonna take my paper, and I'm gonna rotate it 90 degrees. So 2, I know, but I have to turn my paper to the right in order for it to go to the left.
Oh my God. Hey!
Okay. If I'm rotating 90 degrees, what quadrant is this gonna end up in? This one. It's gonna be here, right? What are you doing? Yes.
Oh, wait.
Back shelf in the box. Okay, well, yours, I'm not gonna go through this one. Okay. Yes. Well, let's just say, let's, okay, rotate 90 degrees and then reflect y equals negative. Just stop talking, everybody. This is so annoying. Right in front of your face, there's a brown box. Left, left, left. But people freaked out when I said rotate 90 degrees. Okay, do you agree if we rotate counterclockwise, we'll go from here to here? Okay, so I am going to turn my paper this way so that when I go to 2, -4, oh, look at where it turns out. And then I go to 4, 0, and then I go to 5, -4? Wait, what?
Yeah, 5 should be. Yeah.
Oh, whoops. Like that? Okay, then if we go about y equals -x. I don't think this is right. Okay. Okay, Addie is very excited and so is Aiden and Stella. Aiden, what's your question? No, not right now.
X and then 0 and then y minus 5.
Okay, so let's try it. If we rotate 180, I'm now upside down. So I have this guy, and this guy, right? Are we good here?
Yeah.
And then if we shift them all down 1, 2, 3, 4, 5. 1, 2, 3. Wow, okay. There it is. Layla, I can't hear Layla. Stop.
What if you?
And then reflect across y equals what? This is very interesting. Okay. Okay, if we go across the y-axis, we would go here, here, and here. Oh. Like that, right?
That wasn't even me.
Did you laugh?
No, that was not me laughing.
We have less than 20 minutes left of class. Just stop. Like, I should not even be at school today, but I'm here because I need to teach you, and you're treating me like crap. Just be quiet when I'm trying to talk. Layla is going through her transformation. Let's all give the time for Stella. Let's all give the time for Layla. And then y equals 2.5, -2.5, like this guy right here. Oh my goodness. Look at that. That's clever. Did anybody else do that one? Who did this one? Okay.
I'm 100% wrong.
He's just trying here.
Well, maybe because somebody took my pencil and I had to go get one and.
Okay. So let's try again. Here's number 3. We are starting, hey Carson, we are starting with ABCD. How do we get to EFGH? Try it. You can work with your elbow partner, that is totally fine.
I should reflect across. Y plus this, and then y minus 5.
Would you reflect across?
Y2.
You're not? Oh, mine works too.
There's a couple different ways. You seriously still don't have your notes out? Do you know how frustrating that is for me? That I've asked you to do something and you refuse to? Okay, Tyler, what did you write down? Okay, Emily. For what? Okay, raise your hand if you did this or in the reverse order. Okay, good. Who else has a different one? RO? Does that work? Okay,
I still don't.
Oh, yes.
I don't get it.
so they're saying if I take this and I reflect it about the line x equals 2, and then I shift it down 5, there's my shape.
Oh, yeah.
Okay, this is what I came up with. Apparently I was, oh no, just kidding. I had the first one. Is the grass green?
Yes.
Okay,
This time of the year, it's more like a.
all right. Let's go to number 4.
Really.
So let's plot 2, 2, 3, 1, and 1, 1. Keegan, your classmates have asked you to stop talking, multiple of them. And if you think giggling is any better than talking, you are wrong. There were like 10 of you. Hee hee, hee hee, hee hee. I don't know why you've picked RO to be.
It's always been on.
Because it always is on.
It's because Jordan started it last year. It's just always been on.
It's tough.
It's upside. Wait, I don't care.
Oh, it's upside down. Interesting.
So it's a reflection of the.
Okay, so first of all, we need to determine if these figures are congruent. So Dalton, are these congruent? Okay, so we would write triangle ABC is congruent to, how would we need to name the next one? Okay, and Dalton, you think you know how? How did we get from one to the other?
Oh. The line in the middle, they like lifted it across the middle.
This line in the middle, what is this called?
The line in the middle. X-axis.
Yes, it's labeled for you right there.
Yeah. Yeah, the whites and the blacks are like fading.
The whites and the blacks,
Yeah.
He's colorblind.
but the whites and the blacks fade into each other
Yeah.
with white and black?
Yeah.
Well, I could see like with colorblind, like purple and red or purple and blue. Okay,
That's why I don't watch old movies, because I can't tell the color.
yeah. So you're the first one that I have interacted with where the colorblind affects black, white. Cause usually it's like, usually I have kids who is like red and purple, like they can't tell the
I'm
difference, or like
colorblind.
green and orange.
So like, if two colors are mixed together, I can't see. Nobody
All right, we're gonna come over to here. Okay, so we're back. We're back to 109. We're back to 109. So here's the deal. I have parallel lines. So if I take this guy and I reflect it over this line, and then I take that and I reflect it over the parallel line.
Wait, it makes 9.
109. Let me color code things for you, except on. Are you really?
No, yeah, he actually is. He actually is.
So Ben, do you know what color this is? Oh, see, yeah, blue.
No, you don't.
Hold on, right now, we don't want it. Okay, so. Okay, so that blue segment is going to be reflected across this line to get to here. I'll highlight it in orange. Okay, then I have this parallel line that it's going to reflect a second time. Okay, so fun fact. If I draw a line that connects these three coordinates, it's going to be perpendicular. Another fun fact. Whatever the distance is between my two perpendicular or my two parallel lines, this point to this point is going to be double that. Okay. So like if we come down, like turn the page again to this example right here. Okay. A translation maps UV UV gets mapped to which one first? U prime, V prime. Okay. Okay. Now, if I highlight this right here, this U to U prime, who's perpendicular to that?
Okay.
And technically, they're both going to be perpendicular. Okay. Not congruent. And look at this right here. Totally is. Okay. Now, we also know that V double prime is an image from V because K and M are parallel. Okay, we know that those can go from one to the other. All right, now here's the big kicker. The distance from K and M is 5 inches. If that's 5 inches, what's our distance from V to V double prime? 10 inches. We double it. Go back to here. Look, guys. This is a theorem. Whatever this distance is, then A to A prime is twice that distance. B to B prime, twice that distance. Okay, one more theorem to talk about. If we have an angle of rotation of X degrees right here, then when we map this guy to this guy to this guy, that angle is gonna be twice as much. So for example, if we go back to this number 10, do you see how this is 60 degrees right here? So if I'm asking you for the angle of rotation from A to A double prime, what is that gonna be? We double it, 120 degrees. Okay. That's what that theorem says.